Hey guys, welcome back. Today we're going to be proving congruence using our transformations. Our learning target today is to define, understand, and apply the rigid motion transformations as we have been for the past couple weeks. Our success criteria is going to be able to apply translations, rotations, and reflections, all three movements that we have been studying so far. We're also going to map out a series of rigid motions, so numerous movements. And we're going to use those movements as proof that two figures are congruent. So let's take a look at the key idea here. It says a two-dimensional figure is congruent to another two-dimensional figure if you can map one figure to another by a sequence of rotations, reflections, and translations. The symbol congruent, okay, let me write that a little bit bigger for you. Okay, it's like an equal sign with a little squiggle over it. That's what congruent means. The word congruent, that's the symbol for it. It literally is read as is congruent to. So if you look at this graph here, we can actually map ABC onto A prime, B prime, C prime by first reflecting it over the y-axis. If I do this, I'm counting A is 1, 2, 3, 4 spots from the y-axis, so we have to count 1, 2, 3, 4 in the opposite direction. So there's A. B is 1, 2, 3, 4, 5, 6. So we have to count 1, 2, 3, 4. I've run out of graph here. It should be 5, 6 back over this way. And then C is 1, 2 spots away. So 1, 2. There's C. So that's the first movement. And then if we were to translate 3 to the right and 2 down, we would get A on top of A prime, B on top of B prime, and C on top of C prime. So the two motions that we would have to map ABC onto A prime, B prime, C prime was first a reflection over the y-axis, then a translation, 3 right and 2 down. Okay, so that's just a little intro to the main idea here. These steps that we write down, that's the proof. That's what shows one triangle is congruent or the same as the other triangle. So let's do this in another example, and be aware that there could be multiple ways of being able to make one figure sit on top of the other. So don't feel like if I do this example one way that you couldn't do it another way. In fact, I'll show you two different ways of how to do example 1. The first one that a lot of students will probably think of is two movements, which would be first to reflect across the x-axis. Okay, so if I count for A, that's 1, 2, 3, 4 units away. So 1, 2, 3, 4 in the opposite direction. There's A. B is 1, 2 units away. So 1, 2 in the opposite direction. There's B. C is 2 units away. So we got to do 2 units in the opposite direction. And D is in line with A. Actually, I labeled that. Not labeling the primes. There we go. Because the primes are over on the blue figure. So now that we've done the first movement, you guys could see, oh, now we can actually reflect one more time. We're going to reflect across the y-axis. Okay, so when we reflect across the y-axis, we see that B sits on top of B prime, A sits on top of A prime, C would sit on top of C prime, and D would sit on top of D prime. Now, you could have also, instead of doing two reflections, you could have done a rotation of 180 degrees. Okay, so a rotation of 180 degrees would just be one movement, and you would see A sit on top of A prime, B sit on top of B prime, C sit on top of C prime, and D sit on top of D prime. You could even check this using your patty paper. So let's have you give this a try in your first U try. Try to think of, since this is a square, it's going to be difficult, think about where the letters, where the vertices are going to move. Okay, because a lot of students will probably think this is a reflection, and it might be a couple of different reflections, but it could also be a rotation. So please write down a movement or a series of movements that would map JKLM onto J prime, K prime, L prime, M prime. All right, in this second example, we're going to prove if triangle JAR is congruent to triangle LID. So when it says, is one triangle congruent to another, that's really proving. You want to prove that they are congruent. Now, the way that they're listed actually tells you which letter matches up to which letter. Because before, we would have A go to A prime, B go to B prime, and we could tell they were supposed to land on top because they had the same letter. Well, the order to which they write these tells us which letter maps to what. So since J is first, J is going to map to L because L is first. A is second, so A maps to I because I is second. And lastly, R is going to map to D because D is last. So now I kind of have an idea of what letters are going to land on top of what. It might even help if you color code, or if you don't have any markers, to mark like shapes around each of the letters so that you can kind of imagine if it's supposed to twist, like turn, like a rotation, or if it's supposed to do a mirror image. So I'm going to do J is going to be like a triangle. Same with L. D is going to be a circle, same with R, and then A is going to be a box, same with I. So now I kind of have a better understanding of what I need to do to orient the triangles, and it really doesn't matter which triangle you go from. You can move JAR to LID, or you can move LID to JAR. I would be reading your proofs, and I would follow along with what you write to make sure that you did it correctly. So I'm gonna map LID onto JAR. So the first thing that I'm seeing is if I were to take this triangle, LID, and I were to reflect it over the x-axis, then I get the circle on the bottom, I get the box towards the left still, and then I get the triangle up towards the top, kind of like in this triangle. So I'm going to reflect it and see what happens. Now, this is what you're going to have to do. You may have to test something. And if it doesn't work out, that's why you're working in pencil, erase and start over. So I'm going to test a reflect. I'm going to reflect triangle LID over the x-axis. Okay, since D is on the x-axis, it stays there. So that's still D prime. L is 1, 2, 3, 4 units away from the x-axis, so count 1, 2, 3, 4 in the opposite direction. There's L prime. And then I is 2 units away, so count 2 units in the opposite direction. There's I prime. Connect the dots. And you can see the triangle. So now you should be able to see, okay, and I'm going to use a different color here. Here was the triangle. Forgot to label this one. Oh no, it's there. Okay. This one was the box, and this one was the circle. Okay, so now it actually is oriented the correct way. I just now need to scoot it over. It looks like I need to go up 1 and left 4. Okay, so my second movement will be to translate translation, or I should use the word translate, that would sound better. Translate triangle LID left 4 and up 1. Okay, there's our proof as to why the two triangles are congruent to each other. When it says explain, all those words that we just wrote out that I circled, that's your explanation. You can say the two triangles are congruent because if you reflect triangle LID over the x-axis and then translate it 4 units left and 1 unit up, it will land on top of triangle JAR. So why don't we have you guys give this a try in your second U-try. It says, which two triangles are congruent? Then I want you to describe a sequence of rigid motions that would map one triangle onto the other. If you need help, please raise your hand and ask questions, but try to test movements first before you ask for any help. See if you can orient the triangle in different ways and experiment with what movements will move the triangle where. Alright, so in this last example, we're still going to prove two triangles are congruent using the rigid motions, but this time they tell us they want 3 different rigid motions. So we're going to have to think of 3 different movements to get ABC to sit on top of DEF or vice versa. So, and it does say in the directions we want to map triangle ABC to DEF. So make sure you're following the directions. If it doesn't say what it wants you to map, then you can choose whichever triangle you want to move. But right now it's saying move ABC. So again, just try to experiment. And also make sure you understand that the order to which the letters are listed tells you what they want you to map to. So A is going to map to D, B is going to map to E, and C is going to map to F. So I'm going to make some markings again, just like I did last time. A goes to D, B goes to E, and C goes to F. Okay, so I'm brainstorming right now. How can I move one figure to sit on top of the other? And I think what I can do, and it does say 3, what I'm thinking right now in my head, it would probably only take maybe 1 or 2, but let's experiment. First, I'm going to try reflecting over the x-axis. Okay, and see what that does for me. So 1, 2, 3, 4, 1, 2, 3, 4. There's A prime. B is 1 unit away, so 1 unit in the opposite direction. 1, 2, 3. 1, 2, 3. There's C prime. Okay. So far I've changed its orientation slightly. I think I need to do one more flip. I think if I were to reflect this over the y-axis now, that I might be able to get the triangles to orient the right way. So let's try to take A prime, B prime, C prime and reflect it over the y-axis. Let's see, A is 1 unit away, so here's A double prime showing 2 movements. B is 1, 2, 3, so 1, 2, 3 in the opposite direction. There's B double prime, and then C is 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5. There's C double prime. Okay, so it looks like I have my triangle oriented the correct way. Actually, no, I don't think it's oriented quite right. So this is an example of, I don't think I'm able to get the triangle to sit on top of the other one in only 3 movements, because I've already done 2. And I can tell that this side right here is supposed to match up to this side right here. So it's not actually oriented the right way yet. So let's try something else. So this is why I'm saying you need to be working in pencil. Okay, so I'm going to erase my work and I'm going to try a different approach. Okay, and if reflections don't work, that's probably an indicator that you need to try a rotation of some sort. So the first thing that I'm thinking about for a rotation is 180 degrees. And in a 180 degree rotation, all we need to do is make the points opposite signs. So if A is at 1, 4, if we rotated 180 degrees, we just need to make each x and y the opposite sign. So A prime would be -1, -4. So right there, there's A prime. C is, looks like 5, 3. So we need to make both of those negative. So -5, -3. There's C double prime, or not double, sorry, just prime. And then B is, looks like 3, 1. So that needs to change to -3, -1. So there's B prime. Okay, so I rotated 180 degrees, and if you notice, rotating 180 degrees in one motion gets you to the same spot it took me to do the 2 reflections. So, again, I need to figure out some way to flip this triangle so that this side ends up over there. So I'm thinking if I try to reflect again, it's going to change and mess up the orientation some more. So again, I don't like the rotation that I did. So again, we're working in pencil. And I know some of you guys are probably frustrated that I'm making you erase and try again. But this is literally the process you have to go through if you're going to try to experiment and get these triangles to sit on top of each other. It's going to be frustrating sometimes. You got to get over that. You're going to have to experiment. You're going to have to erase. So maybe instead of a 180 degree turn, maybe I'll only turn it 90 and then see if some reflections can take place. So if I rotate 90 degrees, I have to flip the coordinates, and I'm going to show this in arrow notation off to the side here. Okay, so I've got A, which was at 1, 4, B at 3, 1, and C at 5, 3. If I rotate this 90 degrees, I'm supposed to flip the X and the Y and then think about what quadrant it lands in. So if I flip 1 and 4, it becomes 4, 1. 3, 1 becomes 1, 3. And 5, 3 becomes 3, 5. And then all 3 of these points, A, B, and C, are in the first quadrant. If we rotate it 90 degrees, it's going to end up in the second quadrant. The second quadrant is negative, positive. So I'm going to make all of the X's negative so that I see negative, positive on all the points. Okay, so now I'm going to plot these points. Okay, and I'm just gonna plot like right over what I wrote, because I wrote it in the second quadrant, and that's where all the points are gonna end up. So I'm just gonna plot right on top. See, -4, 1 is right there. -1, 3 is right there. And then -3, 5 is right there. This was A prime, B prime, and C prime. Okay, so I've rotated it, I've changed the orientation slightly. I'm thinking now, okay, I'm imagining, well, what could I reflect it over now to get it to orient the right way? And I'm thinking I can reflect it back over the y-axis and my orientation should be good. So A is 1, 2, 3, 4. So 1, 2, 3, 4 in the opposite direction. There's A double prime. B is 1 unit away, so 1 unit in the opposite directions right over there. There's B double prime. And then C is 1, 2, 3, so 1, 2, 3 in the opposite direction. And it's okay if you have your triangles overlapping. Okay, and now I can definitely tell that this side here, from A to B, A double prime to B double prime, is supposed to match up with ED. They're actually located in the right spots now. So now I can tell, all right, I have to now translate it left 2 units and down 3 units. Okay, so let's write all of what we just did down. Okay, the first step that we made was to rotate. Okay, we rotated triangle ABC 90 degrees. That was our first movement. Then we reflected triangle A prime, B prime, C prime over the y-axis. Then, lastly, we translated triangle A double prime, B double prime, C double prime. 2 units left. And 3 down. Okay, so those were our 3 movements, and I would recommend the first movement you make, if possible, be either a reflection or rotation. Save translations for last. Don't try to slide the image or slide the triangle over right on top of the other one right away and then start spinning or reflecting, because if you do that, the reflection is just going to move it away anyway. It's going to move it in a different direction. So start with either rotations or reflections. So let's have you guys experiment and give this a try in your U-Try. Again, make sure, this is going to be tough. Make sure you are testing things, working in pencil, and erasing and trying other things, seeing how you can orient the triangles in the right way. And make sure you're mapping the correct points onto the correct points. G should land on top of J, H should land on top of K, and I should land on top of L. Go ahead and give this a try. So here's your close and check question. Please figure out, given the figure A, B, C, D, E, F, if it's congruent to L, M, N, P, Q, R by circling the sequence of rigid motions that maps A, B, C, D, E, F to L, M, N, P, Q, R. So look at the picture, maybe experiment a couple things. You could even read through the multiple choice and do what the multiple choice says to figure out if one lands on top of the other. So go ahead and show me you know what you're doing in this close and check. Alrighty, that wraps up the lesson for today. We applied translations, rotations, and reflections in all 3 examples. So example 1 through 3. We mapped out a series of rigid motions. We did that in both example 2 and 3. And we proved 2 figures were congruent, showing what transformations took place. And again, that was examples 1 through 3. So go ahead and you can start on your Google form homework. Please make sure you ask any questions you need, and have a great day.